Okay, ladies and gentlemen of geometry, this is solving systems of substitution by substitution. So it's basically solving systems. So we're taking a little step back from geometry to use some stuff. So whenever you're solving systems, there's two big ways: substitution and elimination. Substitution is this. So solve one of the equations for one of the variables, substitute into the other equation, solve for what's left, and then substitute that back and get the original equation. So basically what that means is isolate one of the variables and then substitute that into the other equation, solve for that one variable, and then substitute it back in and figure out what the other one is. Now, every once in a while you can get a couple situations like this where you get infinitely many solutions or no solutions. If you're doing your algebra correctly and somehow magically get a statement like this, like 7 equals 7 or 2x equals 2x. Well, that's going to be a true mathematical statement. And if that's true, then that means there's going to be infinitely many solutions. Likewise, if you're going along and you get something that's never true, you get like 2 equals 7, or 2x plus 1 equals just, that's a bad example. So if you get 2 equals 7 or something like that, that's going to tell you that you have no solutions there. So if I look, 10x plus 2y equals 10, y equals negative 10. All right, so this one's screaming to get solved by elimination. Here's why. Because I get y equals negative 10. Y is already in there for me and nice and easy. So 10x plus 2, but instead of y, I put negative 10 equals 10. So I already know y equals negative 10, so this just becomes a matter of solving. So 10x equals 30, x equals 3, so there I'm done. So my solution then becomes 3, negative 10. Nice and easy. I'm going to start off with a simple one. Gets a little bit more complicated, but I still have a variable by itself. All right, it's the only thing on that side of the equation. So that's what I want to deal with. So you can take 15x minus 5, but instead of y, you put 2x plus 3, and that's going to equal 30. All I did was replace y with what y is equal to. So this becomes 15x minus 10x minus 15. Be careful of signs, and make sure you distribute that all the way through. So this becomes 5x at 15. So 5x equals 45, so x is going to equal 9. Now, don't leave it like this, you're only halfway done. So I've got to substitute this back in. So y equals 2x plus 3, which means I take 2 times 9 plus 3, so y is going to equal 21. So 921 is going to be my solution there. Elimination. Elimination is exactly what it sounds like. You are getting rid of one of the equations. Okay, you're not substituting anymore. You're canceling out one of the variables, and you're going to solve for the remaining variable. So, take a look. For this one, I'm staring at y because I have 5's in front of both y's, and because I've got a plus and a minus in front of there. So I want to add these two, because here's what's going to happen. I'm going to get 7x. This is going to become 0. This is going to be 14. So a little division, x equals 2. Now I need to substitute this back in to either one of these to solve. So I'm going to have 4 times 2 plus 5y equals 6. So little subtraction. 5y equals negative 2. Y equals negative 2 over 5. Then my answer, 2 and negative 2/5. So elimination here. This one's going to be a little bit tougher because as nothing really jumps out as being by itself or have the same thing in front. So I've got to do a little math here. So since I've already got minus 4 plus, those are opposite signs, I want to deal with those two. So I'm going to multiply this top one by 7 and this bottom by 4. Here's what that's going to do. Right here, 21x minus 28y equals 70. I'll rewrite this one right below it. 20x plus 28y equals 12. So now add these two. okay? Because here's what that did. That put negative 28 and positive 28 right next to each other. So now if I add these two, I get 41x. This becomes 0. This becomes 82. Little division, x is going to equal 2. So now substitute this back in. So I'll take 3 times 2 minus y. Doesn't matter. I could have put 2 back into this equation as well. All right, so I take 6 minus 4y equals 10 minus 4y equals 4. So y equals negative 1. So my solution is going to be 2, negative 1. So if you find P and Q so that this figure is a parallelogram, so now transferring this into geometry mode, all I do is this. This is equal to this. This is equal to this. So I get 2P plus 3Q equals 11. 5P minus Q equals, sorry, this should be 18. This should be 11. So now, a couple different ways I can do this. I do have Q by itself, so I could work some things around and do substitution, or another way I could do it is elimination if I just multiply this one by 3. Here's what that gives me. 15P minus 3Q equals 33. Now I've got minus 3Q plus 3Q up here. So now if I add this one to this one, that's going to give me 17P. The Q's go away. 18 plus 33 is going to be 51. A little division. P equals 3. So now substitute that back into one of those and figure out what you're dealing with. So if I take 5P minus Q equals 11, so that's 5 times 3 minus Q equals 11. So that's going to be 15 minus Q equals 11. So minus Q equals minus 4. Q is going to equal 4. So my answer is going to be 3 for P, 4 for Q. All right, time to get to work. Get going on this and ask me questions as you go and get this stuff figured out. Thank you for playing.